All right. Have you ever looked at a massive software project? You know, the kind with hundreds of developers all working at once, and just wondered, how does that not collapse into a complete mess? Well, today, we're going to pull back the curtain on the discipline that brings order to that very chaos. We're talking about software configuration management.
So here's our game plan. First, we'll dive into the kind of chaos that SCM is built to prevent. Then, we'll nail down what SCM actually is, break down its most important jobs, and finally, we'll check out the tools that make it all happen.
Okay, let's start with the problem. You've heard the saying, too many cooks in the kitchen, right? Well, imagine they're all trying to add their own secret ingredient to the same pot of soup at the same time. It's a recipe for disaster. And honestly, that's what software development can feel like without the right process in place. No, really, think about it for a second. If you and I both try to edit the exact same file, whose changes actually get saved? And what if my new feature accidentally breaks the bug fix you just spent all day on? This is the fundamental problem that software configuration management was born to solve. Because without a system, it is an absolute minefield. You've got developers accidentally overwriting each other's work. Trying to undo one bad change without breaking 10 other things becomes a total nightmare. You completely lose track of who changed what, when they did it, and why. Figuring out the project's real status? Good luck. And there's nothing stopping someone from making an unauthorized change. It's just pure, unmanageable chaos. So how in the world do we fix this? Well, that brings us right to our solution, Software Configuration Management, or SCM for short. It's the set of rules and procedures that brings sanity back to the whole development process. At its very core, SCM is all about one thing: tracking and controlling changes. That's it. It's a formal process that's specifically designed to protect the integrity, the quality and the consistency of the software as it grows and evolves. And this quote really gets to the heart of it. SCM isn't some optional extra you bolt on for big projects. It is absolutely essential. The simple fact is that multiple people will always need to work on the same parts of a project, so you have to have a robust system to manage all that collaboration. Okay, so we know what SCM is and why we need it. But what does it actually do? Let's break down the core tasks, the real nuts and bolts that make the whole thing work. It really all boils down to two main jobs. First, you've got configuration identification. This is basically where you decide what stuff actually needs to be controlled. Is it the source code, the design documents, the user manuals? You have to identify all the moving parts. Then, once you know what you're watching, comes configuration control. That's the actual process of managing changes to make sure everything happens in a smooth, orderly fashion. Now, this is where the magic really happens. Remember that chaos of developers overwriting each other's files? This simple model, called reserve/restore, is the elegant solution. A developer basically reserves a piece of the code, which locks it so nobody else can mess with it. They work on it in their own private space. And when they're done, they restore it, checking the new, improved version back in for everyone else to use. It's a simple idea, but it is the absolute foundation of orderly collaboration. And you can see how those basic actions build into this complete cycle. It all starts with identification, knowing what you're managing. Then change control acts like a gatekeeper for any modifications. Version control is like a time machine, saving snapshots of your work so you can always go back. And finally, auditing and reporting close the loop, making sure the process is being followed and that everyone is on the same page. Each step just flows right into the next, creating this really solid system. So that's the theory. But how do developers actually pull this off in the real world? Well, that brings us to the tools of the trade, the software that powers the whole SCM process. We can trace the history of these tools all the way back to early Unix systems, with things like SCCS, the source code control system, and RCS, the revision control system. These were the pioneers. They introduced the revolutionary idea of storing just the differences between file versions instead of a whole new copy each time. That was a huge leap forward. But today, let's be real, the undisputed king of the hill is Git. So what makes it so popular? Well, for one, it's distributed. That means every single developer has a full copy of the project's entire history. This is a total game changer, because if a central server goes down, the project isn't lost. There's no single point of failure. It also uses something called a checksum to guarantee the integrity of every file, so you can always trust that your code is exactly how you left it. But hey, as powerful as Git is, it's not perfect for every single scenario. Because it's free and open source, there's no 1-800 number to call for support. You're relying on the community. And for huge companies, trying to get it to play nice with a complex web of other internal tools can sometimes be a real headache.
It's also so important to remember that this is a huge ecosystem. It's not just about managing source code. You have these massive tools like Microsoft's Team Foundation server that manage the entire life of an application, from the initial idea all the way to deployment. And on the other end, you have automation tools like Ansible, which take these exact same SCM principles and apply them to configuring whole networks of servers and storage. The core ideas are truly everywhere. So, to wrap it all up, software configuration management is what takes that potentially chaotic, error-prone mess of development and transforms it into a process that is orderly, traceable, and truly collaborative. It's the invisible framework that lets teams of people build incredible things together.
And that kind of leaves us with one final thought. We've been talking about code this whole time, but think about it. These same principles, tracking versions, controlling changes, managing collaboration, how could you apply them to other complex projects? You know, like a legal team working on a contract, a group of writers creating a film script, or architects designing a building. The applications, once you start looking for them, are pretty much endless.